Hello, I hope you are all having a wonderful day. I am here to show you an informational video about liquid-liquid extraction created by myself, Andrew Straffen. We're going to start off with the history of liquid-liquid extraction. It all started in 1909 with the first commercial use of liquid-liquid extraction for the refining of petroleum, or crude oil. The method for refining petroleum in this manner was called the Edelianu process and was created for the petroleum industry by Lazar Edelianu. It involved the extraction of aromatic compounds from kerosene with sulfur dioxide as the extraction solvent. Here we will see the basics of liquid-liquid extraction to help you understand the process occurring throughout the demonstrational portion of this video. Liquid-liquid extraction, in short, is the use of one liquid to extract a compound from a different liquid, though it is not quite that simple. The solvent you use must be miscible with the compound you are extracting and immiscible with the liquid you are extracting the compound from. There are normally two different layers that result: the aqueous layer, which is polar, and the organic layer, which is nonpolar. The solvent often forms the organic layer, while the aqueous layer is often the liquid the compound is being extracted from. When the solvent is added to the mixture, the more dense liquid will be at the bottom, which is often the aqueous layer, with the less dense liquid sitting on top, often the organic layer. The shaking of this mixture will result in the transfer of the compound you want extracted to the solvent layer. The bottom layer is normally drained out and the top layer poured off so that no contamination occurs, as it would if they were both poured out of the same place. This process is normally completed a few times to ensure that the entirety of the compound was extracted by the solvent. Before you begin, here are some of the materials needed for liquid-liquid extraction. For starters, you will need a separatory funnel, a ring stand with a ring clamp to hold the separatory funnel, a funnel, an extraction solvent. I will be using hexane, a liquid with the compound you want extracted. I am extracting benzophenone from distilled water, and 2 Erlenmeyer flasks to pour out the aqueous layer and the organic layer. Now, of course, I know this goes without saying, but I cannot make a video about a laboratory technique without mentioning that you must follow your lab safety precautions when completing this extraction process. I wanted to note that this was not buprenorphine, it was in fact benzophenone. I had a long weekend working as a pharmacy technician and work was still on my mind. I apologize for the mix-up and I hope this clarifies everything. To start, as you can see here, I have labeled all of my beakers and flasks. This is an extremely important step that helps ensure nothing is mixed up or contaminated with another substance. You want to always make sure that you do this. To start, I am showing you what the mixture of benzophenone and distilled water looks like. I'm using a separatory funnel to conduct this experiment, and I have a 250 milliliter Erlenmeyer flask placed under it to allow myself to quickly drain out the aqueous layer. As you can see, I am pouring distilled water through a funnel and into the separatory funnel. I then add the benzophenone, followed by the hexane solvent. I am extracting benzophenone from its mixture with water with the solvent hexane, as hexane and water are immiscible, but benzophenone and hexane are miscible, allowing hexane to extract benzophenone from its mixture with water. I chose to use benzophenone as the compound being extracted, so as a viewer you are able to witness the hexane extracting out the compound from the water. I am showing you the separatory funnel, and if you look closely, you can see the solvent hexane is on top of the mixture of water with benzophenone, as it is less dense than water. Now I will begin the extraction process, but first you need to open the stopcock to release any pressure that is built up inside the separatory funnel, and close it after. Then you will shake up the separatory funnel to mix the solvent hexane with the mixture of distilled water and benzophenone. You will then open the stopcock once again to release any pressure and close it before mixing again. You will complete this process a total of 3 times, as I have just done. Now there will be an organic layer on top, which consists of the solvent hexane with the compound benzophenone, and the aqueous layer will be on the bottom, which consists of distilled water. First, you need to pull out the glass stopper to allow you to pour out the liquids. To ensure that nothing is contaminated by being poured out of the same place, you will be draining out the aqueous layer through the bottom and pouring out the organic layer from the top. As you are draining out the bottom aqueous layer, you will want to slow down as the meniscus reaches the stem of the separatory funnel to ensure that you are able to close the stopcock right before the top organic layer starts to flow through. After that, you will pour out the top organic layer. Once finished, you will want to place the separatory funnel back into the ring clamp on the ring stand. After ensuring that the stopcock is closed, you will want to place the funnel into the top opening of the separatory funnel and pour the aqueous layer back into the separatory funnel to continue with the extraction process. Then, you will pour in some of the solvent hexane to extract what is left of the compound in the aqueous layer. Once finished, you will put the glass stopper back into the separatory funnel and repeat the procedure you completed to mix the organic and aqueous layer. Once again, opening the stopcock to release the pressure and closing it before shaking the separatory funnel. Then opening the stopcock again to release the pressure and closing it before continuing with the shaking, and completing this process a total of 3 times as you have just seen. At this point, you will proceed with the draining of the aqueous layer and the pouring out of the organic layer. Just as before, you will take out the glass stopper to drain out the aqueous layer into its Erlenmeyer flask, stopping right at the meniscus to ensure that none of the organic layer was drained out of the bottom, and then finish by pouring out the organic layer from the top of the separatory funnel into its Erlenmeyer flask. Now, just as before, after ensuring that the stopcock is closed, you will want to place the funnel into the top opening of the separatory funnel and pour the aqueous layer back into the separatory funnel to continue with the extraction process. Then, you will pour in some of the solvent hexane to extract what is left of the compound in the aqueous layer one last time. After putting the glass stopper back into the separatory funnel, you are now at the final extraction point in this liquid-liquid extraction process, and you will once more repeat the procedure you completed to mix the organic and aqueous layer. Once again, opening the stopcock to release the pressure and closing it before shaking the separatory funnel, then opening the stopcock again to release the pressure and closing it before continuing with the shaking, and completing this process 3 times as you have just seen. Now, for the final step in this liquid-liquid extraction, you will once more proceed with the draining of the aqueous layer and the pouring out of the organic layer. Just as before, you will take out the glass stopper to drain out the aqueous layer into its Erlenmeyer flask, stopping right at the meniscus to ensure that none of the organic layer was drained out of the bottom, and then finish by pouring out the organic layer from the top of the separatory funnel into its Erlenmeyer flask. As you can now see here, with the flask holding the organic layer, the solvent hexane was able to extract out the compound, benzophenone, and now the aqueous layer is left with just distilled water in it. It has no more benzophenone. So in summary, liquid-liquid extraction is able to work because the solvent and the liquid you are extracting the compound from are not miscible, but the compound being extracted is miscible with the solvent. This allows the solvent to extract the compound from the liquid without mixing with said liquid. And after multiple runs of the process, the solvent will have extracted all of the compound out from the liquid. It is important to note that you want to do multiple runs of this process with small amounts of the solvent rather than one big run with a large amount of solvent to ensure that the solvent extracted all of the compound, it did not leave any behind. It would not work as well with a large amount of solvent because of the distribution coefficient, which, in layman's terms, only allows the extraction of a particular amount of the compound. So, no matter how large the amount of solvent, only a certain amount of compound will be extracted per run. So you will want to use multiple runs with smaller amounts of solvent to ensure that as much of the compound was extracted as possible. Now this was just a very brief overview of the distribution coefficient, as it would not be able to be covered in this short of a video along with the other material. However, what brief overview of the distribution coefficient that was discussed should be enough to help you understand why you must use multiple extractions with a small amount of solvent rather than one extraction with a large amount of solvent. As well, I cannot mention the distribution coefficient without saying this about it. The distribution coefficient is what determines the amount of solvent used per run and how many runs you need to complete to extract the compound using liquid-liquid extraction. Here you will find my work cited. Well, that's all folks, and I hope you have a wonderful day. Stay safe.